Internet is crappy today, so the recording might be a little bit janky, but hopefully not totally useless if you need it. Let's go over the homeworks, shall we? We need, oh, I think I had her send me enough, but I think I forgot the book again. That's volume 1, that's useless. Let's see if I had her send me enough. I think I did. She can't save me today, she's at work. Let's see. Where is Bree? Did that little kid ask me if I wanted some beer? Is that what just happened? Is that what I heard? I don't know if that's what happened. I think that's what I just heard. I think I heard, hey, Mr. Sean, do you want some beer? That's funny. Let's see. What numbers did we do? 8 through 28. And the answer to number 8 is possibly angle C is congruent to angle Y, angle H is congruent to angle W, etc. Does that sound accurate? Okay, good. Maybe we're cooking. Yes, I will. That one more time. 8. Angle C is congruent to angle Y. Angle H is congruent to angle W. Angle F is congruent to angle S. And then CH to YW equals the measure of HF to the measure of WS equals, the measure of FC to the measure of SY. 8. Let's see. 10. Angle A is congruent to angle V. Of course, all of these would be symmetric as well, right? If you wrote it angle V is congruent to angle A, that's also fine. Right? Angle B is congruent to angle X. Angle D is congruent to angle Z. Angle F is congruent to angle T. The measure of AB to the measure of VX equals the measure of BD to the measure of XZ equals the measure of DF to the measure of ZT equals the measure of FA to the measure of TV. Number 12 is somewhere. There it is. No, because angle L is not congruent to angle W. Number 14 is yes. Triangle BDC is similar to triangle FGC because B is congruent to F, angle D is congruent to angle G, angle BCD is congruent to angle FCG. Number 16 is, turn the page. No, something along the lines of the ratio of the lengths of the hockey rink and air hockey table is about 2, and the ratio of the widths is about 1.7. So the ratios don't match. Number 18 is 7. Number 20 is 2. 22 is 1.2. So the perimeter of ABCD is 56 yards. The perimeter of QRST is 12 yards. 24 is 12.5. 26 is 20.25, and 28 is 75 feet. And there were no proofs, and there was much rejoicing. Go grab a book so I can read for your questions easier. Why didn't you help me remember volume 2 of geometry? Bruh. Okay. All right. what questions do we have, kids? 24. Did we do one more lesson too, or did we just do this one? That's what I thought. That's what I was afraid of. We got this. We can do it. 24, you said. Number 24. Got a couple of similar triangles. Where is, oh yeah, I remember, put them in here. I have to hide my colored markers because on Sundays, it draws the little kids in, and the problem is I wouldn't even care, except they leave the caps open, they end up using a pencil or some nonsense. That's how this happened. So I hide the color ones. I leave the black one so the adult Sunday school can write whatever chicken scratch happens to be. I've been looking at that for 2 days. I came in here to take a picture of a thing, and I still can't figure out what OF stands for in this context. Maybe that's a T, but then it would be I don't know. I don't quite understand. I'm sure it made sense Sunday morning, but I don't know what it means. So we've got triangle WZX and triangle SRT. This is a 6 and this is a 5. And up in the instructions, it says the triangles are similar. It says the stuff that's already written there. It also says the perimeter of SRT is 15. And we're supposed to find what? The other perimeter. What should we do? They're similar. We know two things about similar figures, right? We know something about their sides and something about their angles. What's true about their angles? Let's start with the one that we're not dealing with, so we can remember all the things. What's true about angles in similar figures? Yeah, the corresponding ones are congruent. So Z is congruent to R, angle, LZ, great. What about the sides? They have to be proportional. What about their perimeters? How do we get perimeter? We add up all the sides. So you think their perimeters are also proportional? Probably so. Let's build a proportion. What fraction are we going to put over here? What? 5/6? Yeah. Good job, Joe. You're carrying the group today. Okay. What are we going to put in this one? Definitely 15, but top or bottom? Which one does the 15 go with? This one or this one? Oh, you have to say it's this one, because yeah, that's the one. So this one. So it would go with the 5 or the 6? the 6. True enough. Now what? Yes, cross multiply. That's right. What's 6 times x? 6x, true enough. What's 5 times 50? Yes, that is what I meant. 5 times 15. 75. Sounds accurate. Now what? Divide by 6. So x equals what? 12.5. If we were going to write units, it doesn't give us like what units. Would they be units to the first, second, or third? To the first. It's a perimeter, so it's a distance. That's right. Good guess. True enough. What other questions from this lesson? That's weird. That's got fun. Sure. We could do 22, I think. Bunch of words. Rectangle ABCD has a width of 8 yards and a length of 20 yards. Rectangle QRST, which is similar, has a length of 40 yards. Find the scale factor. Oh no, scale factor. Scale factor is difficult only because we use the word scale in 2 different things, and in one context it means one thing, and then in another context it means like the inverse of that one thing. Learn scale factor first in middle school, maybe in pre-algebra. I know we cover it in pre-algebra. I don't know whether it shows up before that in middle school. And it's been a couple years since I've taught it there, so good luck to us. Okay, so we got rectangle, ABCD. We got another rectangle, QRST. And ABCD has a width of 8 yards and a length of 20 yards. And rectangle QRST is similar. It has a length of 40 yards. Find the scale factor of ABCD to QRST. So, what does scale factor mean in plain English? It is a factor. Scale factor is factor of scale. That's true. That is true. If I go to the model section of Hobby Lobby, and I go and I find a scale factor car that is 1 to 400, what does that mean? Am I buying something that's as big as the real car? No. How much smaller is the car that I'm buying than the real one in that example? I said 1 to 400, so no. Because you go buy a model, it's like this big, right? Real car, big, yeah? So it tells you on the box, this is this much scale, like in a legit model. It's like, this is 1/100th or 1/400th or 1/10th or whatever, the size of the big thing. That's what we're trying to figure out here. What is the scale factor between this and this? So, A, B, C, D, the ones that match are these ones, right? So 20 to 40, we just need to reduce that. So this one is what you said, right? 20 to 40 reduces to what? 1/2. So the scale factor is 1/2. Or 1 to 2, you could write it either one of those in this context, and it would be great. 1 to 2 scale factor. Any other questions from this lesson?
What was the answer to the perimeter one of this, of 22?
22. Oh, I didn't see that it asked that too. Let's see. So find the scale factor. Okay, so let's finish the problem. I guess I should keep reading, huh? So if the scale factor is 1, and wants the perimeter probably of the big one, I bet. Perimeter of each. Okay. This one, how do we find the perimeter of this one? We already got everything we need. 8 times what? Not time, that would be the area, right? So that would give us 8 times, length times width is the area. So how do we find perimeter of a rectangle? 8 plus 8 plus 20 plus 20. We can write it shorthand, right, as, writing D's instead of P's. The perimeter, you could write it 2 times 8 plus 2 times 20, which is the same thing as 8 plus 8 plus 20 plus 20, right? And we end up with 40 plus 16, so 56. It's got units, doesn't it? Yards, right? Now, what about this one? So how do we find the width of it? We are given the length. We need to know the width of it. Somebody give me a guess. What number do you think it is? I like that guess. What? 16 sounds like a great guess. Where'd you get that number from?
Because QRST is double ABCD.
Correct. Because it's double, we just double this number. Great. So the perimeter of this one would be 2 times 16 plus 2 times 40. What's 2 times 16? 32. And 2 times 40 is 80. So what's 32 plus 80? 112 yards. Those yards are the first because we're finding perimeter. If it was area, it'd be yards squared. And if it turned into a rectangular prism, it would be yards cubed. Because that's how dimensions work. I saw a good video talking about dimensions the other day in one of my Grace classes. I'm teaching a class that I titled Math is Actually Cool, but then the directors and the people changed the title to Math is Art, Art is Math, which I think is relatively fitting, so that's fine. But I went down this rabbit hole preparing for different things for this class and started looking at 1.53 dimensions, and it was pretty cool. Y'all might have even thought it was fun. What other questions from this lesson? Okay, so look at the next lesson. This one I don't have the key to, so we're gonna have to YOLO and do it the best we can. What did we do? 10 through 24 maybe? 26? 28? 8 through 28. Proofs. Let's see. Was it 2 through 24 on this one? On 7-3? He's right. Determine whether triangles are similar. I'm going to do my best to kind of look at the numbers and think through, and then we can come back and circle back if we need to. Number 2 wouldn't be similar. Number 4 probably is similar. To write the similarity statement to I for sure. Number 6, angle similarity. So number X would be somewhere in the 8 to 10 range. We can look at that specifically in a minute if we need to. This is number 8. We've got a cell phone tower casting 100-foot shadow. Same time, 4-foot-6 post near the tower. Cast a shadow of 3 feet 4 inches. Find the height of the tower. It's going to be. Wait. Find the height of the tower. Is that what it just gave us? Cell phone tower. It casts no, it tells us how long the shadow is. Set a proportion, solve it. 3 to 4, 4 to 6. So probably in the I don't know. We'd have to do the math. We can do it in a minute. Number 10 is similar because angle. No. Wait. Has angle. Number 10 doesn't give us enough information. So we can't say for sure that it is similar. So no, or else probably a better answer would be maybe on number 10. But they definitely don't give us enough information. Number 12. Yes, because of angle, because of those parallel lines, we get corresponding angles, and then we've got a common angle at the top at J. Number 14, you'd have to do the math. Probably yes. That was 47, would be 90, 106, and that minus 84, and that is probably, we'd have to do the math to see. Let's see. Number 16, got angle, so they're definitely similar. You set a proportion to solve for X. On number 18, we have angle, because all right angles are congruent. So the similar actually this, on number 18, all 3 triangles are similar, I think. Because definitely the 2 smaller ones are. That's an altitude, so they are, all 3 triangles are actually similar because of a theorem we may not have seen yet. Number 20, the 2 little triangles are similar because of angle. Set a proportion, solve for X. Number 32 has got a number as an answer. Number 24 is how far we went. Is that correct? No, we decided it was 2 through 24, didn't we? Trust. Proportion. What ones do we want to look at? Sure. Number 20, we have this triangle, more or less. I didn't draw it right at all, but we'll get there. Got this is 22, and this is also 22. And this is a right angle, which means that the triangles are similar. We've got 2x plus 1, and we have 2x plus 1. Interesting. No, minus 1. I was about to say it's an isosceles triangle, but it doesn't look like it. 12 and 20. Let me label some letters. A, C, F, B. This is one of those that it is, the trick with it, you know it's because they're similar, you're going to set a proportion, right? And they're definitely similar because we've got angle, angle, so it's similar for sure. The trick with a problem like this is we need to figure out where the corresponding parts are, right? That's the potentially tricky bit to this problem. All right, does this side go with this one or this one, right? The one across from the 90 is pretty easy. These two go together, right? So, but we need to figure out which ones go with which ones. And we do it by matching up the letters with the angles, right? The C and the B go together because these are both 22, right? So, angle C over the measure of angle B, those are going to go, those are going to go together. This is really, whoa, that's ugly. Try again. Those two go together. C goes with B. I don't know what symbol to put here. How about a little squiggle? That'll work. They go together. What does F go with? It does. It goes with F. Goes with F. True enough. You're about to say the wrong thing. You're like, that's not right. F goes with F. Right? They don't. Oh, they do give us a letter for this vertex. So A goes with D. Right? What? Right. So triangle AFC is similar to triangle DFB. Ask for the determine, identify the similar ones. So that would be the answer to the first bit. These could be in different order as long as the correct ones matched up. Right? So you could say CFA is similar to BFD, and that would also be true. But the ones that go together have to go together in order. Right? Savvy so far? Great. So, CF goes with which one on the littler looking triangle? BF. And then AC goes with which one on the littler triangle? DB. And those are all the ones that we know. And so we just need to put in numbers here. So CF is 12. BF is 2x minus 1. And AC is 20. And BD or DB is 2x plus 1. That was a creepy laugh. Having all kinds of interesting sounds. Some little kid offering me a beer and some sort of creepy laugh next door. What should we do now? Cross multiply. I agree. What do we have to remember when we cross multiply on these? Something muy importante. Yeah, we have to distribute. True, true. So 12 times 2x is what? I'm going ahead and distributed it, which is you're correct. You were 110% correct, but I bet we can handle because because we're writing it down with good colors and all the things, we can remember what's happening. So what's 12 times 2x? It's 24x. And then 12 times 1 is what? You don't know, 12, yes. And then this one, we've also got to distribute. So what's 20 times 2x? 40x. And then what's 20 times negative 1? Negative 20. Now what? Sure. That's fine. And what's 24x minus 40x? Y'all have calculators. If we're struggling in our brains, we have our tools. Not 20 something. But that would be an easy accidental mental math mistake to make on this one. Negative what? 16. Sounds quite reasonable. That's crazy. Now what? Subtract 12. Sounds fine and dandy. Negative 16x equals what? Negative 32. And then we divide by negative 16, and we get x equals what? 2. Now we need to double check whether it wants x or whether it wants us to plug that back in and find the sides. Let's see. It says find each measure, so probably just x. Doesn't really, that, there's a lot of things I like about this book and a lot of things I don't. That's how it always goes. Eventually I'm going to write my own, but got to have the time to do all that. But that is a vague direction because it could be angle measure or whatever, but it probably just means x. Anyway, what other questions from this lesson? What? 28, the proof. We might do the proof. If there's not any other questions, it's not a bad idea, even though it wasn't assigned. No, we only went through 24. Well, good job. Did you do good on it? If there aren't any other questions, we can certainly look at it. Wouldn't be a bad idea at all. We're kind of narrowing in on less proofs at this point in the class. Can't remember if there's a proof on this test or not. I'll look it up. Let me see. Let me look at the test and see. Actually, it'll be faster since I have these. Just look at the key. That'll tell me quickly whether there is or isn't. I know there is not one on the next test for sure. Because the next test is trig. We do trig proofs later, but they're much different and not until pre-cal. quadrilaterals. Portions of similarity. Let's see. Recipe. There is a proof. Yes, there is. It's more like proof. The proof is more like the other one, the 27 one. We might do that one instead. Because the proof you're doing on the test is proving, instead of proving that the corresponding parts are proportional, it's proving that two triangles are similar. Did we do in this lesson the proofs for, we didn't, right angle similarity? Yeah, no, that's later. Yeah, I am remembering correctly. Good. So, to prove two triangles are similar, you have all the ones that are all the three that are covered in this lesson. You can get angle, angle, side, 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 or side, angle, side. Keeping in mind that if it says side in similarity, we're talking about proportional, not congruent. If they were congruent, then they wouldn't just be similar, they would be congruent. So let's do 27. Yeah, that's a good idea. I like this plan. Let's do it. So, we are given a couple triangles. One like this that is labeled X, Y, Z, or Z if you prefer. And another one that is A, B, C. We are given that triangle X, Y, Z and triangle A, B, C are right, and the measure of XY to the measure of AB equals the measure of YZ to the measure of BC. Okay. So labeling and thinking through what our given bits are. The right angle is given. Which, what does that tell us about angles, angle Y and angle B? If they're right angles. And we know those are the right angles because they're the middle ones in the list, right triangle list. If they're right, then what else are they? Congruent, because all right angles are congruent. Let's see, X, Y, so this side to this side equals this side to this side. This is a short proof. Okay. What should we write in our proof? Probably what we just said, first of all, right? That if we want to go ahead and label all of the things, we could say that angle Y and angle B are right angles because of the definition of a right triangle, right? True enough. If you didn't put this line on a test, I wouldn't count off any points. This number 2 line. Now this number 3, because of the nature of this proof, you would need to put this number 3 in there. And that is that angle Y is congruent to angle B because all right angles are congruent. All right angles are congruent, right? So we got they're congruent. We've got the sides are proportional. What can we say now? They're similar. True enough. Triangle X, Y, Z is similar to triangle A, B, C because why? What is our justification? We've only got 3 options right now. We've only got 3 options for proving triangles are similar. We have side, side, side similarity, angle, angle similarity, and side, angle, side similarity. Side, angle, side. The sides around the congruent angle are proportional, and we've got a congruent angle. So it's side, angle, side. I like to put side, angle, side similarity on there because to keep it from being confused with side, angle, side congruence. I wrote triangle twice. Makes sense. Do we have any other questions other than any of the proofs on any of these ones? Because if not, for grins and giggles, we might as well do 28 because it's got several review bits in it. Bro. Are we sure we don't have any other ones? I mean, it's just, a lot of them are just like reducing the fractions. Does it match? Or cross multiply. Does the number match? Right? So they're not necessarily hard, but that doesn't mean you don't have questions on them. So are we sure we don't have any questions on any of the other stuff? You're sure. Got's this. All right, let's do 28 because he's got several bits and bobs that are worth keeping in our pockets because we know that topics come back around in geometry. And so keeping old theorems in our brains is helpful. And this one has got some things going on. We're told it's trapezoid, and we're supposed to prove that measure of dP to the measure of PB equals the measure of CP to the measure of PA. We're told it's a trapezoid. So all the things that go with a trapezoid are true here, right? Let me label what we're looking for so we can see where we're going. So dP to PB and CP to PA. Okay. So we've got this triangle involved, right? Because that side, and we've got this other triangle involved. I'll label them red and brown so we have something to talk about. Those are the 2 triangles we're interested in. So if we can get that those 2 triangles are similar, then we can get, excuse me, then we can get that they're their corresponding sides are proportional, right? That's kind of the pathway we're headed towards. So, if that's a trapezoid, what do we know about it? The angles are congruent. Which ones? It's a good thought, and I figured somebody was going to say that, but no, we don't know that because it does not tell us that it's an isosceles trapezoid. It just says it's a trapezoid. We could maybe try to prove it's isosceles, but that might be doing too much. What makes something a trapezoid? That's what we need to think through. Only if it's an isosceles. Still trying to go through isosceles, which makes sense. It looks like isosceles, but we don't have enough information to say that yet. So that's not what makes something a trapezoid. How do I know that a shape is a trapezoid? What things have to be true? There's really one criteria. Oh, two criteria. It is a quadrilateral, 4 sides. It does have 4 sides. That's true. So what makes it specifically a trapezoid, not a rectangle or a square or a kite or a rhombus? What makes something? There's what? You're almost right. No. You were closer with the first thing. It only has one set of parallel sides. So if it's trapezoid, it has one set of parallel sides. That is true, which is useful because then we've got all the parallel line things. We've got alternate interior, alternate exterior, we've got same side, we've got corresponding, we've got all that stuff. So saying those are parallel could be quite useful to us. Because if we can get a couple angles are congruent, then we got angle-angle similarity, and we're off to the races, right? So, AB is parallel to DC because definition of a trapezoid. Right? Okay. So it could be useful, it often is, if we have parallel lines, if we go ahead and extend the lines out so we can see. So this is a transversal, crossing these parallel lines. And we've got this other transversal coming out here, right? All right, so we've got this big transversal here, and we've got this big transversal there, right? So, we've got all of the parallel lines theorems. Same side, alternate, and corresponding. Which of those 3 categories has congruent angles? Because supplementary doesn't help us as much. It could if we had to, but congruent is more helpful. Which ones gives us congruent? Is it same side, alternate, or corresponding? It's 2 of the 3. You have a 67% chance of guessing right. Alternate is one of them, and corresponding. Corresponding is less useful because corresponding would have to go outside the trapezoid. But alternate is quite helpful to us, right? Because we could say this angle is congruent to this angle. Those are in the triangles we're interested in, right? We could also say this angle is congruent to that angle, and then we're pretty much home free. So how do I name this angle? There's a couple of different possibilities. ADP or ADB, either one of those would call it great. So, angle ADP is congruent to angle, and what would this one be called? CBP. CBP. Let's go ahead, because it's the same justification, let's go ahead and get these two, right? So we've got DAP is congruent to angle BCP. And that's same justification for both. Alternate interior angles. So we've got this congruent to this, and this one congruent to this one. Can we say the triangles are congruent? No, it's not congruent. We cannot say they're congruent. But can we say they're similar? Yes, we can. What justification? Angle, angle. PD is similar to triangle BPC because angle, angle. If they're similar, what's true about their sides? Proportional is the word you're looking for. Yes. So we can say what we're trying to prove. The measure of DP to the measure of peanut butter equals the measure of CP to the measure of PA, because sides of similar figures proportional. SIDS, that probably is a word, but not the one we're trying to say. Any other questions on this lesson, kids? The trick with most of the proportional ones is writing the correct proportion. What is congruent to what? And so the learning, making sure you know how to do that, and then you're off to the races. We'll do 7-4 next time. Parallel lines and proportional parts. Which they kind of snuck in 7-2, one that kind of goes with this lesson. That happens sometimes where we see something early, and prove it one way, and then we get a shortcut later. I will see y'all on Tuesday.